Imagine stepping outside on a clear, starry night. You look up at the night sky and countless stars twinkle back at you. Have you ever wondered, which is the biggest star among them? It's a question that sparks curiosity and wonder in many of us. Let's embark on a journey through the cosmos to uncover the mysteries of these magnificent celestial bodies. Galaxies are like grand homes for stars. They are massive clusters of stars, gas and dust, each holding millions, sometimes even billions of stars. Our universe is teeming with about 100 billion galaxies, and each galaxy contains around 100 billion stars. When we gaze at the night sky, we're looking at an unimaginable number of stars. But as incredible as it sounds, we can only see a tiny fraction with our naked eyes. Among all the stars in the universe, only about 6,000 are visible without a telescope, and half of them are below the horizon at any given time. Because stars near the horizon are obscured by the Earth's atmosphere, we can actually see only about 2,000 stars at most. Even though that number is small compared to the total, each star we see has its own unique story and significance. Now you might be wondering, which of these stars is the biggest? To answer that, we first need to understand what a star really is. In the world of astronomy, a star is a celestial body that produces energy and emits light through a process called nuclear fusion. Our Sun is the closest star to Earth, sitting about 150 million kilometers away. It's the star that gives us light and warmth, making life possible on our planet. Sometimes people refer to Earth as the blue star, but technically Earth isn't a star, it's a planet. Planets like Mercury, Venus, Earth, Mars, Jupiter and Saturn revolve around the Sun, forming our solar system. There are about 100 billion stars in our galaxy, the Milky Way, and 100 billion galaxies in the universe. It's truly mind-boggling to think about. Stars are born in nebulae, which are vast clouds of interstellar material and gas. These stellar nurseries give birth to new stars, which then go through various stages of life depending on their initial mass. If a protostar's mass is less than 75 times that of the Sun, it won't become a typical star, but will instead become a brown dwarf. Brown dwarfs are fascinating objects. They can't sustain nuclear fusion, so they aren't true stars, but they aren't planets either. Stars with masses between 75 and 45 times that of the Sun become red dwarfs. These stars are small, not very hot, and not very bright. Despite their modest characteristics, red dwarfs make up about 90% of the stars in the universe. They live long, stable lives, quietly burning away without much fanfare. Stars with masses between 45 and 3 times that of the Sun, like our own Sun, go through a different life cycle. After they exhaust their hydrogen fuel, they enter the red giant phase, expanding and cooling as they start fusing helium. They create elements like carbon in their cores, but they can't fuse carbon due to their relatively low mass. Therefore, they eventually shed their outer layers and leave behind a dense core called a white dwarf. Stars that are 3 to 15 times more massive than the Sun end their lives as neutron stars. These are incredibly dense remnants left after a supernova explosion, one of the most powerful events in the universe. However, the most massive stars of all, those with more than 15 times the mass of the Sun, become black holes after their supernova phase. Black holes are regions of space where gravity is so strong that not even light can escape. They can grow by consuming surrounding material and even merging with other black holes. So, what about the largest stars we know of? The biggest star in our neighborhood is undoubtedly the Sun. It's huge compared to Earth, with a diameter 10 times larger and a volume 1.3 million times greater. The Sun is the king of our solar system, holding 99.86% of the total mass of all the objects in the solar system. Yet even the Sun is considered a small star when compared to some of the giants out there in the universe. One of the most famous giant stars is Betelgeuse, a red supergiant in the constellation Orion. It's about 10 times the mass of the Sun and has a diameter over 1,000 times greater. If Betelgeuse were placed where the Sun is, it would almost reach Jupiter's orbit. Betelgeuse is expected to explode as a supernova within the next 100 to 100,000 years, ending its life in a spectacular fashion. But there are stars even larger than Betelgeuse. Take Canis Majoris, for example. This star was once thought to be the biggest in the universe. Located in the constellation Canis Major, it has a diameter about 1/420 times that of the Sun, or approximately 1.9 billion kilometers. If it were in the Sun's position, its size would extend past Jupiter's orbit and sometimes even beyond Saturn's orbit. Then there's RWKF, a yellow or red hypergiant in the constellation Cepheus. It has a diameter between 1/1200 and 600 times that of the Sun, averaging around 1/350 times. WCEPHI is about 11,500 light-years from Earth and is a variable star, meaning its brightness changes over time. Another colossal star is VV-Cepheus, part of a binary star system about 3,000 light-years away in the constellation Cepheus. Its size ranges from 1,000 to 1,900 times that of the Sun. If placed in the Sun's position, its circumference would exceed Jupiter's orbit. Its brightness is 275,000 to 575,000 times that of the Sun. HO Lupi 144, found in our galaxy's companion galaxy, the Large Magellanic Cloud, is another giant. It has a radius 940 times that of the Sun. If placed where the Sun is, its surface would reach Saturn's orbit. This star is surrounded by a thick torus of gas and material with a total mass between 3 and 9 times that of the Sun. NML Cygni, a hypergiant surrounded by a nebula, has a diameter about 1/50,000 times that of the Sun, or 15.3 astronomical units AU, equivalent to 2.29 billion kilometers. If placed in the Sun's position, its surface would extend beyond Jupiter's orbit and halfway to Saturn's orbit. Its volume is 4.5 billion times that of the Sun. UY Scuti, a red supergiant in the constellation Scutum, is about 9,500 light-years away and has a diameter about 1,708 times that of the Sun, with a volume 5 billion times greater. If placed in the Sun's position, its photosphere would engulf Jupiter's orbit and reach near Saturn's orbit. It's one of the largest stars known to humanity. Currently, the largest known star is Stephenson 218. This red supergiant has a diameter 250 times that of the Sun and a brightness 500,000 times greater. If the Sun were a speck of dust, this star would be a colossal giant in comparison. Its sheer size is beyond human comprehension. To put it in perspective, if you could travel around its surface at the speed of light, it would take 8.7 seconds. If you were to fly around it in an airplane, it would take 100 years. Finally, let's talk about the largest galaxy in the universe, IC Waleno 1, located in the constellation Serpens. Its diameter is about 6 million light-years, roughly 60 times the size of our Milky Way. The fastest speed humans have achieved is 17 kilometers per second by the Voyager 1 spacecraft. Traveling at this speed, it would take 6 billion years to cross this galaxy. For us, this is practically eternity. From our human perspective, Earth seems enormous. But when we compare it to the stars, it's just a tiny speck of dust. The Sun, with a diameter about 30 times that of Earth, has a circumference of about 5 million kilometers. Driving a car at 100 kilometers per hour non-stop would take 5 years to circle the Sun once. If the Sun were a 2-meter-wide giant tractor wheel, Earth would be the size of a go-stone, and UY Scuti would be as tall as about 300-400 meters, taller than Mount Everest. Traveling around the Earth by plane takes 2 days, but traveling around Stephenson 218 by plane would take 100 years. Yet even this enormous star is just a grain of sand compared to the vastness of the universe. The scale of the cosmos is truly incredible.